Hello everyone, in this video we'll be solving problem 34. Find first and last position of an element in a sorted array. The problem statement is we are given an array of integers num which is sorted in non-decreasing order. We need to find the starting and the ending position of the given target value. If we don't find the target, we should return -1 as the output. And we need to solve this problem using O of log n runtime complexity. In example number 1, the target given to us is 8, which exists twice in the input array. So its corresponding indexes are being returned as 3 and 4 in the output. But in example number 2, the target is 6, which does not exist in the input array. So we are returning -1 as the output. If we did not have this criteria to solve this problem using O of log n complexity, it would have been a very easy implementation. All we need to do is run two iterations, one from left to right and the other from right to left, and whenever we encounter a value that matches the target, record its corresponding index and return it. But that solution will give us the time complexity of O of n. So we cannot use that. Instead, we'll try to solve this problem, which will give us the time complexity of O of log n. Now let's switch to whiteboard and discuss about that solution. One way to solve this problem is to use binary search algorithm, where we'll use two pointers left and right, and then based on these values, calculate the midpoint of the array, and whatever the value that the midpoint is pointing, we'll compare it against the target. And if the value matches the target, we'll accordingly update the left and the right pointers so that we can identify its corresponding indices. The only added complexity here is we need to identify the first and the last index of the same number. And to get this information, we need to tweak our algorithm. Before we start discussing about the tweak, let's first apply the binary search algorithm to this input. To start off, my left will be pointing at 5 and right will be pointing at 10. The midpoint will be 7. We'll compare the value of 7 to the target. Because 7 is less than the target, it means the target should be on the right hand side of the array. So we'll update the left pointer to point at the next element after mid. For the next run, my right will still be pointing at 10, but my left will be pointing at 8. The midpoint this time will become this 8. Now we'll compare this value against with the target. The value matches, so which means we have found the target. Now we need to calculate the first and the last index. Usually we update the left and the right pointer based on the comparison if the mid is greater or less than the target. But when the mid is already pointing at the value which is equal to target, what should we do? Which direction should we go to? As it is possible that the target could exist on both left and the right side of the midpoint, we need to go in both the directions to identify the first and the last index. Looking at the right side will give us the last index, while on the left side will give us the first index. It is also possible that the mid is already pointing to the first or the last element, so by default we'll set the value as midpoint and try to explore other options if there are more on the left or the right side of the mid, so that we can return the accurate indexes. Similar to the usual implementation of binary search tree, to go towards the left, we'll update the right pointer to midpoint and repeat the entire process. Similar logic for the right, but this time we'll update the left pointer to the midpoint. All of these checks are running under a while loop, and the criteria is to make sure that the left pointer is less than the right pointer. If the criteria is broken, we can stop the iteration, jump out of the while loop, and return the value that the left pointer is pointing at. With this solution, our time complexity is O of log n, as we are using binary search algorithm to break the entire array down into halves so that we can narrow the operation, while the space complexity is O of 1, as we are only using two pointers left and right to calculate the range of the subarray. I hope you were able to understand the explanation. Let me show you how we can implement this using C#. Here is the C# solution. In the main method, I am calling this helper method find position, passing the nums array, the target, and the boolean is first. Depending on the value, we'll either be moving towards the left or the right when the mid is pointing at the target. And we are calling this method from the main method, passing true and false both the combinations. In this find position method, I'm starting by initializing the left and the right pointer to first and the last element of the array, and then starting a while loop until left is less than or equal to right. After that, I'm calculating the midpoint based on the left and the right values and checking if the mid is pointing at the target. If yes, then I'm updating the result to mid. The value mid is pointing could be the potential first or the last element. So I'm saving it for now. After that, I'm checking if is first boolean is set to true. If yes, it means we need to calculate the first occurrence of the target. So I'm updating the right pointer to point to mid minus 1 so that we can go and focus on the left side of the array. If not, then I'm updating the left pointer. This means we are looking at the last occurrence of the target. If the mid is not pointing at the target, we then go inside the else if condition to check if the mid is pointing at a number which is less than the target. If yes, it means that the target is on the right hand side, so we are updating the left pointer. If this condition is also not satisfied, it means the target is on the left hand side, so we are updating the right pointer. Once the while loop is complete, that is, the left is no longer less than or equal to the right pointer, we jump out of the while loop and return the result. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 27% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.